Hello, we're gonna discuss today the accounts and transactions in Ethereum. So while this might be a short lecture, it's quite an important one, and in particular, this particular slide here is really key in understanding how Ethereum works and operates. So we've already seen that an address is basically here stored as a map from an address key towards some data, storage, balance, and a nonce. And what I haven't yet discussed is that there are two types of accounts, or two types of addresses. So there's an externally owned account. So it's an externally owned account that can be, for example, your Ethereum wallet that you store, or it can be a contract. And this is a smart contract, right? So Ethereum typically says that smart contracts are first-class citizens. It means they have their own kind of address generation purpose, and they can issue transactions after they have been called, etc. Right? So they really there's really an emphasis on the concept of a contract. And as you see here, there's actually no code associated to an externally owned account, while a contract does have some EVM code, right? So there must be some EVM code associated to it. The externally owned account doesn't have any storage contents. So if you create an Ethereum wallet with MyEther wallet or MetaMask or so, you don't have any storage there. You don't need it either. While the smart contract has a Merkle storage root. So now the things that are in common is that the account and the contract both have an Ether balance. So you can send coins to an account and then this will increase. And they both have a nonce field. That's the same as I discussed before. It's the number of transactions that were sent from this particular address. Right? It's an ever increasing field. Now, going back to the address itself, how you compute an address, that might be actually quite important if you go deeper into smart contract programming. The address of an externally owned account is simply the hash of the public key, while the address of a contract is the hash of the creator, which is typically an externally owned account, right? So there's an address of an externally owned account, but this externally owned account also has a nonce. So you can basically create a contract address by having the creator and the nonce, and you take the hash of it. So a funny anecdote that comes about basically due to this specific nature of the Ethereum blockchain is that if you have different Ethereum blockchains, for example, there's the mainnet where most people compute, and then there's the Robston testnet or the Kovan testnet, right? So if you have the same public key of an externally owned account, then you can create the same contract address on these different networks, right? So you can basically have the same public key and the same address for an externally owned account on all three of these networks, and you can also have the same contract address on all these three networks if you make sure that your deployer address, which is your deployer externally owned account, uses the same nonce. So there are three types of transactions in Ethereum, and we go very carefully through them because this is quite crucial in the understanding of the smart contract blockchain. So this is kind of the high-level view of how a transaction looks like. The first type of transaction is a send transaction. So this is if you want to send some coins from address 1 to address 2, right? Then you can use the sender and the receiver. So sender would be here address 1, receiver would be here address 0. The signature is performed by the private key that is associated to this address 1. Nonce is, as you know, just the incremental counter. There's no data, right? Because we don't have any data that we want to send. And the amount is the amount of ether that you want to send from address 1 to address 2. Now, the gas limit and the gas price here, these can be set by yourself. So typical values, I think, are for like a simple send, because this is a simple send operation, right? It doesn't have any data, so it's not very expensive. I think when you pay, for example, 30,000 gas, that should certainly work. And gas prices, as we know it in the current Ethereum blockchain, obviously this changes always and might be outdated when you listen to this, but gas prices range from whatever 20 gigaway to 500 gigaway, for example, right? Depending on the network congestion. So this is basically the particular transaction. And if you now if you want to compute what does the transaction cost here, then, for example, you can say my maximum transaction cost will be 30,000 gas times 5 gigaway, and then you can use you can compute how much this would cost in ether, and then resolve this as well in terms of US dollar. The second type of transaction that we would like to look at is the create transaction. The create transaction, as the name says, is a creator. So is creating a smart contract, and it's creating the smart contract with the code that is associated here, that is basically filled in this field, and this is EVM bytecode. Okay, so you're not going to write this EVM bytecode directly. You're going to probably write it in Solidity or Viper or some other smart contract language, but you're going to compile it into EVM bytecode and include it here. And then you're going to decide how much ether you want to allocate to this contract at the beginning of its existence. Creator here again can just be any externally owned account. It can be, for example, this address 1. Signature is the same as before, nonce as well. Gas limit and gas price the same. And then we come to the third type of transaction. It's the call, right? Once you have created a contract, and we have now this address of this contract, then we want to call it. So a contract is only executed if somebody calls it, and this means we have to call it with a transaction, right? And here you specify which contract you want to call. So this can be, for example, the address of the contract, and now the contract itself can have, for example, the function number 1, can have the function number 2 and the function number 3, right? And it can take some arguments there. So depending on which function you want to call, you have to specify here the function that you're interested in to call, and you pass the arguments as well. It can also happen that you want to pass some ether to this call, and then you specify this here in this particular field. So for example, let's say function 1, basically, let's say it sends the amount to address 2. Then if you were to call function 1, because here, for example, you can say this is address 2, right, as a parameter. So if you call function 1 and you pass in the parameter address 2, and you pass into this call as well some ether, let's say 1 ether, then the contract will do another call, right? And he will make a transaction to send coins to address 2, depending on the contents of function 1 that you have defined. So in a sense, you can think of a contract as a program with a list of functions, and these functions are only called if somebody externally calls them, right? So you don't have a main function per se. You can basically call any function of the contract that you're allowed to call, and you're right. This is it's quite flexible, but we will go into these smart contract programming details at a later stage. This is just really important to understand the basic concepts of what a smart contract is. That's quite different from how it operates in Bitcoin. Thank you.